In this video, we're going to discuss time value of money. This should be we should be able to review more than actually, in quotes, learn something here. But this is just a review of time value of money. What is the importance? Every financial decision we make involves estimation of cash flows in the future. And those cash flows in the future do not buy the same amount of stuff that cash flows buy today. So, in order to make comparisons, to make decisions, we need to move money forwards and backwards in time so that we can see the ultimate purchasing power of that money in that period of time. I've provided a link here for my YouTube library. In this particular YouTube library, it's on the time value of money. And there are many videos here on how to solve for various time value questions. So let's talk about the differences, like future value versus present value. We're going to be moving money forwards and backwards. And the right way to assess anything in the future is we need to review it on what you might refer to as an equal playing field, right? Dollars have to be equal in the sense that they have the equal purchasing power. So that's what we're going to use. A timeline helps us for some more complicated kinds of problems. So don't use it a lot, but if you have a complex problem, a timeline will allow you to visualize when the cash flows occur and try to figure out where you're moving the back time, etc. There are three basic cash flow patterns: a single amount, an annuity, and a mixed cash flow stream. I think there certainly a single amount is a lump sum. We don't need to describe that. An annuity is an equal payment for a certain period of time. And a mixed cash flow stream refers to unequal periodic cash flows. From a corporate perspective, most of the projects that we'll look at involve predicting future income statements and cash flows. And of course, in the future, because of differences in inventory accounting, certainly depreciation, how we account for depreciation, those things will require or mandate almost that no future cash flows will ever be equal, right? So they're all going to be unequal. So it's really a corporate finance kind of a technique or concept. So if we look at future values, when we look at future value of a lump sum, and we're just trying to find an investment of the future value, the primary concept involved in time value period is all about something called compound interest. This is where interest earns interest over time. So again, this compounding is what's going to drive and talk about how money ultimately grows in the future. The basic variables that you would find on a financial calculator or in an Excel, PV0 is the beginning amount or the present value. R is the interest rate. Sometimes it will be I divided by Y. FVN, future value at the end period. So this is the end value that we are either solving for or that we know about. N is the number of years. A is the annuity. Sometimes it might be payment. And of course, we might be solving PVA, present value of annuity, or FVA, future value of an annuity. And finally, the variable M. M is, I don't know why it's M, but it's M. It's the periods per year that we calculate interest. And there are only certain numbers that could be. The basic ones are annually 1, semi-annually 2, quarterly 4, monthly 12, daily, 365. If we had bi-weekly payment types of things every 14 days, it could be 26. So each one of these techniques, if you will, obviously has a formula. This is really a great big algebra question. So down below here, we see the formula for solving for present value. So you can use this end part here. That's the one I suggest you use, where you find the present value and you multiply it by 1 plus the annual interest rate divided by how many times you compound interest. That is taken to an exponent of number of years times the number of pounds. So this is the rate, this is the periods involved, and this is the rate per period. So in the Excel formula, the rate that they use here is the rate per period, N per number of periods, payment, right? If this is a investment, we're not talking about payments here. That's another problem. So right now that will be a 0. Present value, in the Excel, present values will always be entered as a negative number. It implies you're spending that money, right? Or you're investing that money. It's a cash outflow. The type, we'll talk about that a little bit later on. But to start with general, the type is going to be a 0. And we'll talk about what that is later in some further discussions. So basic example, right? We're going to save $1,000, pay 7% compounded annually. How much will be there in 5 years? Again, you input the data. Negative 1,000 is the present value. 7% is the interest. 5 is years. 1 is the compounding period. Again, we don't need to know this thing down here, but for right now, it's either going to be a 0 or yes. And the answer is $1,402.55. So again, depending on how you round, we got 1403.55. The answer is pretty close. Okay, so that is how you find the future value of an investment. So let's think about how you might solve in the PowerPoint that you'll be looking at. The next slide is an example. So I want you to solve that example. When you open that, see and make sure that you get the answer. You will find the answer in the notes section. So let's go on to present value. Yeah, this is what's referred to as discounting. Taking money that you think you're going to get in the future and bringing it back to today. That's called the discounting process. The interest rate that we use in these time value calculations, it could be called the discount rate, opportunity cost, discount, required return, cost of capital, growth rate, inflation, right? There's many numbers that represent how things ultimately grow into the future. All of those things, of course, are synonyms for this discount rate. So the formula we see here now is what? It's the future value divided by, now this is essentially what this is referred to here as an interest factor, right? So the present value interest factor is really 1 divided by this. So it's the future value times 1 divided by that. In Excel, the difference here is present value instead of future value. The input is the exact same. Again, remember, this is a lump sum, so the payment will be 0. Future value, you're going to receive this future value. So that's a positive number. The type, again, we're keeping that at 0 for right now. So again, we don't need to know anything further. We'll expand our examples as we go along. So here's our example. We're going to get $2,000 in 5 years. Opportunity cost is 10%. What's that value in today's money? 2,000 is the future value. It's a positive number. Interest rate's 10. 5 is the time in years. If you solve for present value, it's negative $1,241.84. What does that mean? If you wanted to get this $2,000 in the future and you could earn 10%, you would have to invest today $1,241.84. Now, here's what I think is the confusing part. Which would you rather have, $2,000 in 5 years or $1,241.84 today? Which one of those would you rather have? The answer is you don't care. They are equal amounts. They're just in different times, right? For me, I think that's the hardest thing for people to start to understand, is that the dollars that we talk about, even though they're the same dollars, right? Andy Jackson is on the $20 bill. A $20 bill today will buy a certain amount of stuff. That same $20 bill will not buy as much stuff 5 years from now. So to equate that, to be able to make comparisons, we have to move this money backwards and forwards in time. And again, following this slide, there's an example for you to work through to see if you can solve this type of problem. Again, the answer is in the notes. Look forward to seeing you in the next video.